All right, so from the kinematics practice that we did, this is problem number 16, and it reads, a teacher sends her students on a treasure hunt. She gives the following instructions of walking 300 meters north, then 400 meters northwest, and 700 meters east by southeast, I'm sorry. As all the other students walk off following the instructions, Jane, physics student, quickly adds a displacement and walks in a straight line to find the treasure. How far and in what direction does Jane need to walk? All right, so this is a pretty straightforward question that we've done before. The only tricky part is the angle thing that they give us. A couple of them are pretty obvious, but there's another one that is not so obvious, and I wouldn't expect you to know what directions on a compass are equivalent to what angles. But the process of solving the problem would be the same whether they give you the angle or they give you this kind of east southeast kind of thing. So we know that north is going to be 90 degrees if we look at a Cartesian coordinate plane. Northwest is taken to be 45 degrees in whatever quadrant you're looking at. So we're in the northwest quadrant. So we're in quadrant 2 at 45 degrees. So that would tell us then it's 135 degrees from 0. And then east southeast, we find, I had to look it up, but it's 22.5 degrees, and east southeast, if you're thinking about a compass, would be in quadrant 4, so it's 22.5 degrees below 0. So I did just 360 minus 22.5, and that's how I got the 33.7. But everything after that is pretty straightforward and pretty standard for everything that we've done so far. So what I've got to do is, and I've drawn a little picture of the path that they've run to go A to B to C, and they want to know what R is. So what we're looking to do then is we're looking to break these displacement vectors up into components and then add them together, add the components together to end up finding what R is, the magnitude and the direction. So that's what I'm going to do here. So first I'm just going to look at the X. So to do this, we have 300, and the x component will be cosine of 90. And then we have b, which would be 400 cosine of 135, and c, which would be 700 cosine of 337.5. All right, and when I do those out, pop in my calculator, I've got 0, negative 283, and 647. And when I add those together, I get a total x component for my resultant of 364 meters. I'm then going to do the same exact thing for the y. All right, so and now instead of using cosine, though, we're going to use sine. So it's going to be 300 sine of 90, 400 sine of 135, and 700 sine of 337.5. And when I do those out, I find that I get a y component for A of 300, a y component for B of 283, and a y component of negative 268 for C. And we find the sum of those to be 315 meters. So all together now, these are this 364 and this 315. Those are my r sub x and r sub y components. So this is the x and y component. So this would be r sub x equal to 364. And this would be my r sub y equal to 315. And we see that they are components, they're perpendicular, they're sides of this right triangle. So to find out what exactly our magnitude and directions, if you just want to walk in a straight line, all we have to use now is the Pythagorean theorem to find out what r is. So in this case, it would be the square root of 364 squared plus 315 squared, and that comes out to be total displacement magnitude of 481 meters. The next thing that we'll do is we need to find then what angle. And here we have the adjacent side and the opposite side. So that tells me that I should use the trig function tangent. So tangent is going to be, I don't like that color. Let's find a better color. Right, it's going to be equal to the inverse tangent of y over x. Right, so it's going to be 315 divided by 364. Right, so that angle then is going to be 40.9 degrees. All right, so then R is a final of 481 meters at 40.9 degrees. And if we look at our answer options that we have for this multiple choice question, it lines up with answer option A. Right? So again, it's a pretty straightforward vector addition problem once we figure out what these angles are. And that's it. So that was number 16 from some practice questions we had.